By this time, we have tried with the hardware, so we'll go to step 2. According to your opinion, explain how to prevent a switch from debouncing. Okay, I'll explain this concept with the simulation using Proteus simulation software. Okay, so let me start Proteus. When you run the Proteus, make sure you run the Proteus with administrative mode. Okay, if you right click the icon, run as administrator. I am going to open a project from here called Arduino button breakout board. Okay, look at over here. The name of this program that debounces button and toggle play. Okay. So how we do debouncing? This is the software approach. In your theory class, we have gone through two way. One is the hardware approach, other is the software approach. Over here, we are going to see how to debounce the multiple effects of a button by using software. The main concept over here, we just give a delay. So look at over here. The loop starts from here. This is the main function loop of your Arduino Uno program. Now this is the button. We check the button whether we have pressed the button or not. If we press the button, then we wait 20 milliseconds, for example. Again, we check the button. Button is still pressed. Only then we toggle the switch. We go for the action. Look at over here. When we press the button one time, because of mechanical contact, sometimes we get multiple press, right? So to avoid those multiple press, what we do, we give a delay. When we press the button, we give a delay. After the delay, again we test whether the button is still pressed or not. If it is still pressed, then we go for action. So that only one effect. So what happened over here in the code? First, we press the button, then we check it. If the button is pressed, then we give a delay. After the delay, again we check. It is still pressed. Is the button still pressed? Then you go for action. Now, how much time you give the delay? That depends on your system. We have given over here 20 milliseconds. In your system, you can try with the 10 milliseconds, 5 milliseconds. Okay, you can vary the time and find out what is the right delay for the button you are using, because it will vary from button to button. Get the mechanical device. Okay, so after writing the program, just vary the delay to test your physical button so that it is working properly, giving one effect. Now, this is when you press. When you are sure that okay, button is still pressed, go for the action. Okay, after you do the job, okay, after the job is done, release. When the button is released, again there can be multiple effects. During the release, again there can be multiple effects. Look at over here. After the job is done, look at over here. Again, he give 20 millisecond delay. Check the button. Wait until button is released. If the button is not released, then keep on waiting. So once after the delay, you make sure button is released, then you go for the end. So bouncing can happen when you press the button. Also bouncing can happen when you release the button. Multiple release, okay? Multiple release again, release and again contact. So make sure only one effect when you press the button. and only one effect when you release the button. That is not multiple press. Again, when you release, again there can be multiple press and release effect. So you give a delay. Now, how much delay again you will give? Again, it depends on your scenario, on your physical, depends on your physical hardware. You will try with different value. When you find the right use that value. The flow chart you are looking at over here is a graphical way to program your Arduino Uno microcontroller board. You can program Arduino Uno, Arduino Mega. There are several boards it support by using Proteus simulation software. This is the drag and drop method. You don't write a single line of code over here. You just drag the block and drag and drop method. Okay, by drag and drop, you build the flowchart to write the program. And after you test it, let me simulate, let me test the system. So use the play button, run the simulation. So when you use the play button, it compiles your program, generate the machine code, and it simulates your system. So look at over here. This is the Arduino Uno breakout board. This is all the pin over here. This is the reset pin of the Arduino Uno. This is the analog pin, another digital pin over here. Okay. This is the push button we have connected to pin number 2. IO2. Pin number 2, we have connected the push button. And this is the LED at pin number 8. When you drag and drop this block, the connection is done automatically for you. If you want to change the pin connection, you need to modify it. I'll show you one complete example after this. Okay, I will implement complete lab number 4 by using drag drop play method. So you'll get more idea how to work with this Proteus software using graphical approach. So this running the simulation, let me press the button. LED is on. Only one effect. As I again press the button, LED is out. Not multiple effect. Let me do it again. One press, LED is on. I am releasing the button. Still LED is on. One effect. Again I press the button, LED is out. So it has successfully debounced the effect of the button. So this covers your step 2 of your lab sheet. Now we'll go for the step 3. Design the same system using Proteus simulation tool. So let's do it from the very beginning, step by step. Let me close this system. Let me just stop the simulation and file, then close project. So what we are going to do, after opening Proteus, you will select open, select new flowchart. This is a drag drop play method. New flowchart. So let me click new flowchart. So when you click the new flowchart, you need to give a name for your project. Okay. Lab 4. Just lab 4. And then you can give just give lab 4. So click next. Now, over here you can choose the family. You can use either Arduino or Raspberry Pi. Okay, both options. We will choose Arduino. Now, what type of board you are using? There are several boards it support: Arduino Leonardo, Arduino Mega, Arduino Nano, Arduino Uno, Arduino Ion, or Proteus Play and Arduino Cloud. Okay, we pick up over here Arduino Uno, right? If you have the Arduino Mega board, you'll pick up Arduino Mega. So depending on your hardware, you'll select the board. Then compiler, Visual Designer for Arduino 8 here. This is by default. That's fine with us. So click next. Click finish. So when you click the finish button, it will open up two tabs for you. One is the schematic capture. This is the Arduino Uno breakout board, and this is the Visual Designer. Okay. Now we can add peripheral or component from both tabs. Let me do it from here. So what we need to do? I need to use a push button first, right? And use one push button. So let me pick up the push button. Go to the file menu, import project clip. Then there are several folders. Pick up the folder Arduino. Then pick up, find the Arduino button breakout board. Select Arduino button breakout board. Click open and place the button over here. For example. Now, as you place the button, let me zoom it. IO2. By default, it has connected the button with pin number 2 of your Arduino board. By default. If you want to change it, you can double click and change the number. Otherwise, it has automatically done the connection for you. Next thing, I need to use lighting system. 2 rows, right? 2 rows of lighting system. So let's pick up, let's say, per row there are 3 lights. Per row there are 3 lights. You can change the lighting number depending on the need. So file, again, import project clip, pick up the light. Okay. Arduino LED bar breakout board. Okay. Pick up the light one by one. Arduino LED shield. Arduino LED bar breakout board. Arduino LED blue breakout board. Okay. Green and red. Red, yellow, and green. Okay. I think you can pick it up. So pick up a red first. Red color. Then pick up another light. First 15 red. Then let's pick up, I think, blue. Then pick up another color. For example, green. Just little bit do arrangement. Okay. Side by side. So 3 LED. Okay. Again another row. So another 3 LED. You can pick it up. File. Import project clip. Import project clip. Just import several LED. One more LED. We are going to pick it up. So 2 rows of LED. Okay. So when we press the button, first, for example, tail to one way. When we press the button, another direction tail to the right. Okay. So let's first check the connection. This is pin number. Let me just enlarge it a little bit. 8, 9, and 10. 8, 9, and 10. This is it. Another row. Again, same connection. So we need to change it, okay? Because 2 layers of the same pin number. So we need to change it. So double click the pin number. Double click the pin number. Click the locked, unlock it, and give another number. We have used 8, 9, and 10. We have used pin number 2 for the button. Then we can use pin number 3, I, or 11. 8, 9, 10 we have used. Let's use 11 over here. Then 12 over here. Then 13 over here. Okay. So overlapping, just use, if there is some overlapping of the connection, you just change it manually. Now there's the overlapping of connection 8, 9, 10. Okay. This relay and this relay 11, 12, 13. No overlapping. Our push button connected to pin number 2. Our push button in pin number 2. So let me just use the zoom in. So this is a complete lighting system. When you press the button, initially it will go in one direction. When you press the button, it will go in another direction. So let's go to the visual designer. The visual designer, look at over here. We have 6 buttons. 1, 2, 3, 4, 5, 6 buttons. 1, 2, 3, 4, 5, 6. First row, second row. This is the 2 flowchart over here. Look at over here, 2 methods. One is for the setup, other is for the loop. Let me zoom it, okay? One is for the setup. Let me zoom it. It will be easier to understand. One for the setup, other for the loop. Same way you write program in Arduino, setup part and loop part. The setup part, you write the code that will run only one time. That will run only one time. So over here, okay, we write the code that will run only one time, right? Now, in our Proteus, lots of things are done automatically for you. Like in Arduino, normal programming, we have defined which pin is the input, which pin is the output. You have defined by yourself. Over here, those things are you don't need to be You don't need to define those things manually. When you have taken the LED, your software already know this is the output pin. Those pin number 8, 9, 10, 11, 12, 13, they're already the output pin because this is a LED, not push button. When this push button pin number 2, your software knows that it is the input pin. So you don't need to define by yourself. Software automatically takes care of it. Life is much more simplified over here. Just pick up the component, your software already know that it is input or output. And your software automatically configure it for you, depending on the device. Okay? Depending on the device, your software automatically configure it for you. So let's see in the loop mode, add the button. Okay, drag and drop. We have added the button. Now, this is yes. If the button is pressed, one sequence. If the button is not pressed, another sequence. Okay. So we can change swap yes or no. Okay, that means if the button is not pressed, then it will go for one direction. So let me write a subroutine for it. Okay. New sheet. Right click flowchart file. Right click flowchart file and click new sheet. Over here, you can give a name of the new sheet. Rename. Rename sheet. What name we can give? Let's say initial sequence, the default sequence. Okay. Default default sequence. So over here, you define the default sequence of lighting. Okay. So you write the subroutine over here, just drag and drop this subroutine block. Okay. Event block. Drag, click it, drag and drop the event block. And give a name to the event. Okay. Default sequence. Default sequence. Default sequence. So we have given a name, default sequence. So turn on the light in default sequence. Okay. So drag and drop the light. Button 1. LED 1. Better I just expand the LED 1, and there are several options for it: on, off, set, dim, and toggle. So what I'll do, I'll turn it on. LED 1 is on. Again, LED 2 is on. After a delay, let's me give you a delay. This is a delay option. Okay, time delay. Let me give a delay. What delay you want to give? Let's say 1 second delay per LED. Okay, it's a 1 second delay. So what you can do? You can pick up second directly. 1 second. 1 second delay. Okay. So again, after the second light, pick up the third light. I think there are 2 rows, right? So for 2 rows, what you going to do? Both rows is 4, 5, 6. 1, 2, 3. That is 1 and 4. They will be at the same time. 2, 5, same time. Okay. So 1 and 4. They will be same time on. Okay. They're all on the same time. Just let me enlarge a little bit. You can then understand. Okay. LED 1, you see, LED 1 is on, LED 4 is on. Then there is a 1 second delay. After that, you turn on LED 2 and LED 5. LED 2 and LED 5 on. Okay. Then again you give 1 second delay. 1 second delay. Just or 1000 milliseconds, same thing. Okay, 1000 millisecond, same thing. 1 second delay. After that, you turn on LED number 3 and LED number 6. Okay. So after that, LED number 3 on, and LED number 6 on, right? Then 1 second delay. Again, this will continue. Again, give 1 second delay. So let me review our program. Default sequence, LED 1 and LED 4 is on 2 row. Then 1 second delay. Then LED 2 and LED 5 is on. Then 1 second delay again. After that, LED 3 and LED 6 is on. There are 1 second delay. Okay. So this is the default sequence. And what is the another sequence? We'll do opposite of it when you press the button. So let's create another subroutine. Right click the flowchart file, new sheet, and rename the sheet reverse sequence. Rename sheet reverse. Any name you can give. I am just giving a name sequence. Reverse sequence. Okay. So again, write the subroutine. So drag and drop the event block. Same way, just reverse of it. Okay. So this time we'll start from 6. LED 6 and LED 3, right? So LED number 3 first on. Okay, one thing. After turning on the LED, you need to turn it off. We did not turn it off, right? Okay, so let's go to the default sequence. Because when you make it on, all the okay, to turn it off. So after 1 second delay, turn it off. So 1 and 4 turn off. 1 and LED 4 turn off. Okay. After that, turn on LED 2 and LED 5. After 1 second delay, make sure turn it off. Now, if your flow chart is lengthy, you can break it down. Just click for right click and you have split. Okay, so we have splitted the flow chart, and we can go over here. So what we have done, after 1 second delay, we will turn off LED 2 and LED number 5. LED 2 and LED 5 will turn it off because they are on. After 1 second delay, they will be off. So LED 2, LED number 2, turn it off. And LED number 5, turn it off. Okay. After this, turn on LED 3 and LED 6. LED 3 and LED number 6, they turn on. Okay, then give again 1 second delay that we have already given. After this delay, turn it off. So this is LED number 3 and LED 6. So LED 6 turn off and LED 3 turn off. Okay, this loop will continue until you press the switch. This one sequence. This is one sequence. Okay. Now reverse sequence. So it will start from LED number 3. Turn it on. LED 3 and LED 6. Turn it on. Okay. Then give 1 second delay. Drag and drop the delay block. After that, turn it off. So 3 and 6. LED 3, turn off. LED 6, turn off. After turning on 3 and 6, we need to go for 2 and 5, right? 2 and 5. So they should be turned on. LED 2, turn it on, and LED 5. Again, give 1 second delay. Once again delay. Let's split over here, okay? So what we have done, we have gone through, let me just enlarge it. We have gone through LED 3 and LED 2 and 4. Next is the, I think we need to turn it off, right? After the delay, LED 2 and 5 should be turned off, right? Right? They're on. 2 should be off and 5 should be off. After that, we'll turn on 1 and 4. Okay. LED 1 is on and LED 4 is on. Again, give 1 second delay. After that, turn it off. 1 and 4, turn it off. Okay. So this loop will continue. So what we have defined? We have defined two functions. One is the default sequence, other is the reverse sequence. Now on a main program, when button is not pressed, go for the default sequence. So call the function subroutine. This is the subroutine block, call block. Okay, drag and drop the call block and double click and pick up the method default sequence. Okay, and if the button is pressed, go for the reverse sequence. So again, call is the function reverse sequence method reverse sequence. Okay, this is the reverse sequence block. This is a default sequence. It should be visible. Let me see why it is not visible. Reverse sequence. Cancel. This is the default sequence. It's the reverse sequence. Okay, we did not give the name. The problem is that it's not finding your program because you do not give the name of the program. So click the event. Give a name. Reverse sequence. Okay. Now you have given the name, you can use it. Unless you give the name, you cannot use it, right? So now I think reverse sequence available. So when the button is pressed, yes. Okay. And this will continue. So very simple code. Loop. If the button is not pressed, default sequence. If the button is pressed, reverse sequence. Okay. Now the code behind the button, it takes care of everything. You don't need to worry about it. The system has built-in program for it. Okay. So when you compile it, it generates the code. You don't need to worry about the code behind the button. It comes built in with the software. So let me save the project. Save it. Now compile it. Run it. Okay. So it is compiling a project and generating the machine code. Now look at the lightning. First row of light. Red, then blue, then green, I think. Green color. It will continue. Default is red. Then this red color is on. I think let me enlarge it a little bit. It will be more easier to visualize. Red, then blue color, and then green color. So this is one sequence, right? So this is the default sequence. Now press the button. Okay, let me press the button. It will change the order. When you press the button, it will be in reverse direction, right? Yes, that is in reverse order. Look at over here. Now it is reverse order. When the button is pressed, it is in reverse order. Right? And when the button is released, default order. Red, blue, then green. Default order. When the button is pressed, reverse order. Okay. So what we have seen over here, this is a graphical approach. You did not write a single line of code. It makes your life much easier because you don't define by yourself that this output pin or output input pin, the software takes care of it. Just drag and drop the component, it does the connection automatically. And writing code, you can write a bigger code. You can divide the code into several subprogram or subroutine that we have done over here. And you can manage or organize very big project more efficiently using this method. Proteus is a very well-known software, widely used, and they upgrade their software quite frequently, and they add more and more components. Okay, this is the version I'm using. I think 8 point version number 8 point, I think 9. Okay, it has lots of component support, and every version they come up, they add more components. So it is a very good software that you can use for your learning and simulation plus implementing the practical system. Because look at over here, once you write the flowchart over here with the single button click, come over here, Visual Designer, this is the button to upload the code to your hardware. If you connect your Arduino Uno board by the USB cable to the system, just click this upload button. Click the upload button, it will upload the code to the hardware, and then you can use the system independently. Above all, suppose you have designed a system over here and you want to have more control on your code. So you can convert your flowchart into Arduino Uno code directly. Okay. If you just, I think, option project, convert to source project. If you use the button convert to source project, let me just click the button. Once you convert, you see operation cannot be undone. Let's convert. You see, it has generated the Arduino basic programming code for you. So that if you want to use the Arduino IDE and have more control on your code, just copy the code from here, go to the Arduino IDE, and can have more control on your system. So it is a very good software, and it is worth to spend some time to learn the software because it has lots of flexibility and ease of use. Okay, bigger project you can nicely organize and do with this project with this software. Okay, and it support many complex hardware that takes very hard time to implement in normal programming. Okay, especially I think if your project is very big, it is hard to manage. Okay, normally, and over here you can multiple page you can create. Also on the design window, you see on the when you go to the design window, you can use multiple pages to accommodate bigger design. Look at over here, design, new sheet. Over here, you can add more components. As many sheets as you like, you can add, and you can have a bigger project. You can easily simulate over here, and from simulation, you can directly go to the physical implementation. because with the click of a button, you can upload the code to the physical hardware. And even after that, if you're not happy, if you want to have more control, you can convert your flowchart code into source code. And you can take the source code to the Arduino IDE software and can have more control on your system. So any question at this point? So let me save the project at this point. Before you upload the code on the physical hardware, just one more setting you need to do, project setting. In the project setting, make sure you check up the option. That means the processor Arduino Uno, family is Arduino board is 328. Okay, this is the programmer. Then interface Arduino Uno. Okay, so just you need to check these basic settings. Click OK. After that, if you click the upload button, the code will get uploaded to your physical hardware without any error. Okay. So that's all for today, and thank you for attending the class.